In this video, we're going to cover a neat trick that I like to use to easily inject and execute SQL commands and queries. We'll cover the advantages and disadvantages of using this technique in your own code base. Hey, it's Justin Colston with SparkPoint University, where we aim to provide advanced techniques to take your skills to the next level. If you're new here, be sure to hit the subscribe button below and keep in mind that all links we discuss will be provided in the descriptions below. So let's jump right in. Almost every software application built must store some type of data. This data is created, updated, deleted, and queried throughout the application via buttons, user input, and automated processes. However, how can we best access this data? A very common approach, especially in enterprise software, is to use a SQL engine. Some examples are Microsoft SQL Server, Oracle, MySQL, and PostgreSQL. In order to access the data, we must provide code to query or execute against these engines. One approach is to use Entity Framework. An Entity Framework is a great tool. However, it does have a steep learning curve and there are a lot of nuances that must be understood to achieve the best performance. Instead, if you are like me and enjoy the control of writing your own SQL, then maybe consider using a different ORM. Personally, I'm a huge fan of an open source product called Dapper. I have provided a link below in the description. But this tutorial isn't really about Dapper. Instead, it is about creating an abstraction that allows us to easily inject a common service into our repository classes. Stick around and we'll go through a bonus trick where we wrap our service with a decorator pattern for more flexibility. So let's get into the code. The first thing I want to do is walk through the old way of writing SQL in kind of the legacy.NET style. Now I put together a couple projects here under a solution. One is I have a database project, and I have very simple tables. I have a products table, and we'll open this up. We have a name, a product ID, a description, and a created timestamp. Nothing special. And then we have a product attributes table, and this has a product ID foreign key, but then it has a compound key of product ID and key, which is key is really an arbitrary key for a product. And then we have a value that can be nullable technically. So I have this database here. And then we have the program, which is just a console app. We could use this in Web API. And in order to kind of simulate a Web API, I created a configure method. This configure method will actually create a service collection, and then we will add our service that we've created right here. So we have a new SQL product repository, localhost, my database, integrated security, and it implements the iProduct repository that we've created. So if I go to this, you'll see I only have one method, and it's an add product method. Okay, and I notice I have a mistake here. In fact, normally we want to name this add product async because it is a task, and thus it's an asynchronous task. Typically, you like to have the async. It allows you as the developer to know that it's an asynchronous method rather than just a normal synchronous method. So I added that in there real quick. By doing a rename, it automatically changed it here as well, which is pretty cool. I love Visual Studio. So I have this, and then I actually implemented this as well. Now, before we go into the implementation, let's go back to program. All I'm doing is I'm going to get the service, right, from the provider that we configured, and we're going to insert two products, product A, product B. Product A is a set of playing cards, a standard 52 card deck of playing cards, and it's going to have three different attributes. It's going to have the color red, the size of standard, and the brand we don't know, so we're going to say null. Easy enough. Then we have a second product that has basically just a name of microphone. Description's null and attributes are null. I added this in here just to show you that you don't always have to do attributes and description. That we built some code around the idea that they can be null, and this actually adds value to the way we're going to approach this problem. We inject, though, when we're building this repository, if you notice, we actually injected this connection string directly in. We actually had to create this with a new parameter here because of the way that the .NET Core dependency injection system is implemented. Well, I don't like this. I mean, we kind of have to do this no matter what, but we'll see if we can maybe avoid this and fix this later on. For now, let's ignore it. Let's go to the SQL product repository now. Now I've implemented this with one method, add product. I inject the connection string, check to make sure it's not null, of course. And then we go into the actual method. Now this is kind of the old way to do SQL, especially if you're a SQL server. This is kind of the old enterprise way to do it. You basically do some checks at the beginning, right? I put a check in here just to make sure it's not null, but There should be other checks to check name, parameters, attributes, whatever you want to do for your validation. I then have a set of SQL statements. One is to insert the product and return the product ID. And then we have another one that's used in a loop to do to insert product attributes. Okay, this is how I grew up doing this. Is we create these individual SQL statements, then we open up the connection, new connection string. We open it, then we would create a transaction because if one of these pieces fails, we want to fail it all. You then create a command. You pass in your SQL statement and your connection string and your transaction variable, and then you pass in your name, your description, and you execute the scalar. You execute scalar because I want the product ID back. But then you got to check and see if there's any attributes, and if there are attributes, you can do a for loop, and you're going to create the new SQL command, and then you're going to execute this, and then you're going to commit it. This is the legacy way of doing it. But just to prove that it works, because this code works, we're going to hit play. And we're going to let it run. And as you can see, it created a product A and a product B with ID of 15 and 16. We can go to SSMS, SQL Server Management Studio, and we can take a look. I was looking at it earlier just to test, but let's look at 15 and 16. You'll see it inserted 15 and it inserted 16 very easily. Okay, now ignore these. These are just playing around, messing around with the code, but it did insert that. So let's go look at the product attributes. Same thing. As you notice, it only added 15 because 16 did not have attributes. But you can see it had brand of null, color of red, size of standard. This code works, and it works well. For the sake of remembering, I want to clean this out a little bit. So we're just going to delete this database. We'll close all existing connections. And we're going to republish this so we can have a fresh database when we start to do our new methodology. So I'm going to come in here. We're going to stop this. Press enter to quit. We'll close that down. And one way you can do this, just as a neat little note, is you can right click on your database project. I can hit publish. We'll edit this and we'll do, where are you at? We'll just do this one here. And we'll name it my database. Publish. And now it's published. We go back. We'll refresh. There it is. We can actually show there's nothing in these tables anymore. Okay. So let's move on. Now that we have this, we need to create this ISqlExecutor that I've been talking about. So what I'm going to do is I'm going to first create a new assembly. And the reason I like to create a new assembly is because I like to keep these kind of generics, these reusable components outside of my main code base. So let's do that now. So we're going to go ahead and we're going to add a new project. I like to use .NET Standard because it makes it more compatible with other projects. Select class library. We'll go next. We'll put it in this one and we'll say SparkPoint University .SQL.abstractions. This is going to be my abstraction layer, or my abstraction library. We'll use .NET Standard. I like to separate my abstractions from my implementations. A very common approach is to use to do it the way that .NET Runtime does it. They actually separate these things out. And what's beautiful about the way they separate it out is that you can kind of pick and choose what you want to do. You don't have to take everything you want. You kind of leave the dependencies behind. So I'm going to create this abstraction layer where you can choose to use the implementations I have or not, but you're not going to get it unless you need it or unless you want it. So first things first, let's design our interface. So I'm going to say interface here, public interface, ISqlExecutor, the name I commonly use for it. And then we're going to do task, and we're going to do task of T. And you know what? We don't even do the task of T right now. We'll just do task because we don't actually have queries set up in our sample. So all we need to be able to do is execute async. Now, what I like to do is now create a function or I'll use a lambda expression when I use my ISqlExecutor. So what I'm going to do is I want to pass in an IDB connection, IDB transaction, and we will return a task. Very, very simple. Now, we're actually going to run into a problem. I mistakenly said that we're not going to need to return any values, but we do because I'm returning the product ID when I call this function. So I do actually need to pass a generic into this. So here's my very basic ISQL executor. I'm not going to do a full implementation of all the different methods I typically use because I typically do an asynchronous version, a synchronous version, and I'll also have ones that return values and some that do not return values. That's usually about 4-6 methods, depending on which variation I use. For this one, because we only need one, we'll only do one. So I now have my ISqlExecutor interface. I think we need to implement, but the question is, where should I implement this? My opinion is that you may want to use this ISQL executor from MySQL or Oracle or PostgreSQL or SQL Server. I think we need to separate that out into its own assembly as well. First thing I'm going to do is I'm going to rename this so that I actually have a good name here in my file. We'll save. Let's create another assembly. All right. Next. And we'll call this SparkPoint University .sql server. There we go. .NET Standard as well. So because we're doing SQL Server, we're going to create our implementation here. So I'm going to call this SQL Server SQL Executor. We'll rename the class. Now we need to implement our executor. We need to, of course, call this in. Implement. Perfect. Now, like our repository, we need to also inject that connection string. Because what we're trying to accomplish is get rid of that connection string from every repository. If you remember, we are injecting the connection string into SQL product repository. The problem with that is, what if you have 20 repositories or 50 repositories or any number of classes that require a connection string? The reason it requires a connection string is you're trying to execute some SQL. Well, that's kind of a pain to set up, I'll be honest. If you try to do that inside of a services configure method, it really becomes painful to make sure that you do new on all of those. And what if some of those classes take other services? Well, now it's definitely a lot more difficult to inject. I want to make a note here that a lot of people will start using the IOptions pattern to inject connection strings, but the problem with that is that you've now created yet another dependency where you are requiring the options namespace from the Microsoft .NET Core framework. Of course, you can do this, but you've now limited yourself to always requiring that. I personally like to pass in basic types, whether it be an options class that's specifically designed for this, or passing in the raw string itself. Either way, to me, it's nicer to not have to depend on too many other assemblies, frameworks, or other assets. So we're just going to inject, like we did before, the connection string directly. Okay. Make this read only. Perfect. So now what we're going to be abstracting out here is all the information and all the work that's usually done in a repository class. So that's going to include opening the connection, and it's going to include closing out the connection. It's going to do all that work for us, and it's going to execute this executor lambda that we're going to pass in instead of having to do all that work and making sure things are appropriately instantiated, opened, etc. So we're going to kind of redo that code a little bit. So we're going to say var SQL connection equals new SQL connection. Of course, we're going to have to install our library, and we're just going to call connection here. Now we're going to open the connection, of course. Open async. Perfect. Let's execute. So we're going to go await executor. We're going to pass in our SQL connection, but we don't have a DB transaction. What should we do? Well, we can create a transaction here, but that's going to limit our flexibility a little bit. Every time you add a transaction, you have multiple statements. You can sometimes run into deadlocks. You may not always want to have a transaction. So instead, what we're going to do is we're just going to pass in null. We're not going to do anything else other than that, just null. And we'll fix this issue so you can do transactions at a later date. Now this executor returns something, so we want to make sure we return that value. And that's it. Nothing else special here. So let's go ahead and try to implement this now. What we're going to do is we're going to rename this first. Make sure that's clear. We'll come to our program, and we're going to change this around a little bit. So first things first, I want to add a singleton. It doesn't have to be a singleton. It can be scoped if you like to have it scoped. There's a lot of ways to do that. There's a lot of reasons to do that. I like singleton. Whenever I can use it, I like to use singletons. SQL Server Executor. Gotta do it right. That's not going to be correct, but that's okay. I'll fix that here in a second. Let's get that in here, and let's get that in here. So this is not going to be correct because I need to do this. We're going to inject our SQL here. Here's our connection string now. So you see, I still have to pass in the connection string. No matter what, you're going to have to pass it in at some point in time. That's not going to change. But at least in this case, if I have multiple repositories, I won't have to pass it into each one. Instead, we'll show you here in a minute that once we adjust the SQL product repository, you'll just inject ISqlExecutor. You won't have to inject that anymore. And then you can inject other services as necessary. For instance, I a lot of times will store JSON in my database just as a kind of a bulk operation. When I store that, I need a way to serialize that data. I will actually inject an iData serializer into my repositories as well as the ISqlExecutor, and I don't have to do anything extra to make that work. So let's go ahead and now alter our SQL product repository to utilize ISqlExecutor. Okay, so now, like I said, we don't need the connection string anymore here. Instead, what we're going to do is we're going to remove all this, and we're going to inject the executor. All right. So we have that injected now. We need to replace this code out. So we're just going to, for now, we're just going to write directly above it. We're going to return await executor dot execute async. We want to return an int. We won't need that here, and I'll show why in a minute. Got to do that right, Justin. There we go. Now, we don't have a transaction, remember. That's a problem we have right here. We're going to have to figure out how to fix that here in a minute, but before we do that, we're going to just create the transaction manually like we're already doing. So all we have to do to make this work at this point is now copy this piece out and put it here. And we're going to say SQL transaction equals this. We have our SQL connection. So now you can start to see one of our issues here is that this is IDB connection. Well, we don't know at this point if it's SQL Server or MySQL or anything. Now you can derive that depending on how your SQL statements are done. You know, brackets are sometimes used in certain engines, but not others. But if you're writing ANSI SQL, it actually turns out pretty well where you can actually reuse this. For now, we're going to assume we don't know, and we are going to do this a better way, which is basically we have to create the connection at this point. So we're going to say dot create command. Okay, we're going to have to do that. We're going to do SQL command dot transaction equals SQL transaction. SQL command dot and text equals SQL product. And even with the add value, you don't get the niceties of that either. So we're going to have to add this the manual way. See, this is the stuff I don't enjoy. New parameter. All right. Just go ahead and push through this real quick. Well, this might be a problem too. So execute scalar. See, we don't even have async version of this when we use the interface the way it is. That's okay. We'll make it work. But that's an annoyance we're going to have to deal with. Create command. We'll delete this. SQL command.transaction. Transaction. Okay. And like the last one, we do not have the async version, which is unfortunate, but kind of the way it is. Okay. We can remove this old one. We're going to leave it at async even though nothing's using async in here. We'll leave it there for now because we will need it again. So there it is. Last thing we need to do to move on though is we need to go back and make sure that our configuration is correct. It is no longer correct as we changed what we're inputting. Well, luckily for us, because this is a service we can inject, I no longer need to manually new this up. Instead, all I need to do is SQL product repository. And that should make it work at this point. So now we have this being done once, and then every repository after that, we have this. And we can have multiple repositories, and each one, you don't even have to specify the arguments anymore because we can automatically inject now the SQL into it. Let's make sure this runs. Look at that, 1 and 2. Let's just check our work. Could be wrong. No, seems to show up. And everything shows up the same. So we did refactor, but we didn't really gain a whole lot. Let's be honest with ourselves. I mean, sure, we, got rid of some using statements up here, but then we still got to do the begin transaction. And then we got all this other stuff we have to deal with. I'm not a big fan of that. I mean, we really need to clean this up a little bit. So what I'm going to suggest is that we go to Dapper. Using this combination with Dapper really elevates this code to a much cleaner solution. So let's go to the Dapper repository. You can find the Dapper repository on GitHub under dapperlive/Dapper. So here's the URL. That will be in the description below. Reality is that all Dapper does is creates a list of extension methods that you can now utilize to ease the work that you have to do when you're inserting and returning query results. So we're going to install this. We're going to add this NuGet package. It's very simple to do. We're going to add that at the console level. So we're going to manage our NuGet packages, browse, and we're going to just say Dapper. Here's Dapper. Oh, they added a new icon. That's pretty slick. Install. We are installed. Okay, so let's refactor what we have here. We're still going to need the transaction for now. We're going to make that a little bit better here in a minute. But let's go ahead and utilize the Dapper API in that sense. So all I'm going to do is first we're going to execute the first query. And what we'll do is we're going to say, actually we'll just do it right here. Int product ID equals await SQL connection dot execute. Oh, I have to actually import Dapper. All right. We're going to query first or default. Do first async. Actually, we'll do single async because that's actually a more appropriate action we want to take. Okay, and then we're going to pass in the SQL product, and then we're going to pass in our product as a parameter. We also have a transaction, so we're going to pass in the transaction as well. Okay, now You see query single async. Dapper kind of plays with the style of kind of like link. So you can query single, you can query first, you can query first or default. It kind of has that similar link feel to it. Makes it a little bit easier to understand and utilize. So what we do is if you look here, you have your query single async and you have a return parameter. The int is our return parameter because we are trying to cast our scope identity to an int. You then pass in your parameters. Now, in order for parameters to work with Dapper, they have to match the names exactly. So you see I have the parameter of name and description. So on the product model, it must say name and description exactly. So let's take a look at that. Name and description. Perfect. So that's going to work. And what will end up happening then is we will also get the product ID back when we execute the scalar. However, we don't need this code anymore. We can get rid of all of this because Dapper will do all of that for us. Isn't that wonderful? Now we have the problem of the attributes, but same concept applies. We're going to do it a little differently though. So instead of creating the command, we're still going to do the for loop. And all we're going to do is we're going to do await single SQL connection dot execute async. Okay. So now we need the actual SQL, so attribute. And we need to create a model, just like we have in our insert statement. So I'm going to do an anonymous type. Then we're going to pass in SQL transaction. So we have to have that. I don't want to forget about that. So we have to pass in product ID. Remember, it has to be exactly the same casing and everything. Equal to product ID. And then we're going to have key. It's going to be key value dot key. And then value equals key value dot value. Okay, not too bad. We'll then be able to erase this as well. We'll then commit the transaction, and then we'll have the product ID returned, just like it does before. So I'm pretty sure this will break, but we're going to go ahead and hit play anyways and see what happens. And as I thought, it did break. The reason this broke was because we did not have a one-to-one match with how we actually wrote the SQL originally to using a Dapper model. The reason for that is that the description is null, but it cannot be null in the insert statement. So you cannot, since it's a non-null field, we actually have to inject something, otherwise it's going to fail, and that's what's happening here. So we need to correct that. The easiest way to correct this is going to be to actually replace this with an anonymous type as well, with a name equals to product dot name, description equals product dot description, this nullable type. And I should be able to simplify by using a inferred name. Now, if you don't know about this about anonymous types, is that if the actual property name you're using is the same as the name you want, or the property name you want, you can use an inferred type. So in this case, it's going to automatically, this product.name is equivalent to name equals product.name. Same difference. So we'll just do that to make it a little bit simpler on us. But this, we need to make happen. So we're going to hit play again. Now they both work. And if we go look at 5 and 6, you'll see that 5 has all three inserted there, and then 5 and 6 are here as well. That's awesome. I think we did a good job. And look at our code. It is much simpler than it was before inside the repository. So we've made pretty good progress on this methodology. There's a couple things that we need to do. One is we still have the transaction problem, which we'll deal with in a little bit. But we also have this problem of the attributes having to do a for loop, which means we're going through every single one and we're actually performing a SQL execute each time. There are better ways to do this. We're not going to cover it in this video how to bulk upload, but we will go through a bulk upload example using Dapper at a later time in a later video. For now, we have to deal with the transaction aspect. We also want to kind of fix this aspect up. I'm not a huge fan of adding stuff this way in your services. You have to remember as a developer how to do this. My opinion is we need to create a easy to use extension method that will allow people to easily add their executor to their system. So let's do that. The way I like to do this is I like to go into wherever the implementation of the executor is and add a new static class, right? If you've never done extensions before, an extension method is like a pseudo method that you can add on top of another class or interface. We're actually going to create one on top of the IServiceCollection. What we're going to do is iStatic class service collection extensions. We're going to say public IServiceCollection. See, this brings up an interesting problem. If we use this assembly, which right now has no real dependencies on anything else except for the abstractions DLL, we are going to automatically add another layer or another dependency that we will have to be able to use this. That may not be desirable if you're building a framework. So instead of putting it in here, why don't we cancel this? And let's create another layer. There's a reason why I'm creating so many assemblies. For me, creating these assemblies is about creating a framework that you can continuously reuse. When we're working with enterprise software, we tend to not do this. Instead, what we tend to do is just add everything and throw it into one big bucket, the shared library bucket. But then all your dependencies kind of get mixed up together all the time. In order to avoid that soup, it's better to create more assemblies than to create fewer. I know it might seem counterintuitive because then you have a lot of assemblies, but you can always break these out into NuGet packages and just easily reference them from another spot, right? If you use Azure DevOps, they have their own package manager. So I would recommend building smaller assemblies, just like you would build smaller classes or smaller functions. Do the same thing for assemblies. Smaller assemblies are not a bad thing. So we're going to go ahead and create this. We're going to call it SQL Core. I'm naming it this. You know what? We won't even do that. We're going to do this a little differently. I think a better name is going to be extensions.sql. So let's do next on this. And we're going to make this, we'll leave it at .NET Standard. I'm fine with that for now. It won't really matter because we're going to use some .NET Core code, but at least in this sense, we will be somewhat compatible. So we're going to say Service Collection Extensions. It's a static class. And we'll rename it so that was appropriate. Now let's create the Service Collection extensions. So we're going to say IServiceCollection. Got to be static. IServiceCollection. Now we can inject this because that's what we're using this for. And we're going to say add SqlServerSqlExecutor. There we go. And we're going to pass in a connection string. All this method's going to do, and I forgot this, I apologize. This IServiceCollection services there. All this is going to do is we're going to do what we did in the last one, which is going to be services.add singleton ISqlExecutor. We're in the abstractions, and then we're going to do new SQL Server Executor. SQL Executor. Got to name it right. And then we're going to pass in connection string. Perfect. Okay, so we've just now made ourselves a SQL Executor extension method that we can now easily understand instead of having to know the exact interface name and all these things. Like, you have less control, I admit, because now it's always going to be a singleton. It may not be desirable, but use what you need here for now. You can always change this, or you can add overloads to this, where it might be maybe you pass in the singleton versus the lifetime itself. You might actually pass in the dependency lifetime. You can do that as well. For now, I'm going to leave it this way because I'm going to use singleton. But it's very feasible to extend this methodology further and further, give your framework more flexibility. One thing I like to do here is I like to actually rename the namespace to the dependency injection one. The reason I like to do that is because it will live with the IServiceCollection, which means this will show up automatically when you go to add services if this namespace has been imported. So if I go back to program now, instead of doing add singleton here, I can say add, we got to add the Gotta add the dependency here, so let's add project reference. We're gonna go to extensions.sql. Perfect. And without importing that namespace, I can actually say SQL Server Executor. I can remove this code. And now we pass this in. Add SQL Server Executor. That's pretty slick. So nothing should change. Everything still works. We're still doing the exact same thing, but we moved it out. What was the advantage to moving it out? There wasn't a whole lot of advantage you may notice there, but one of the things we can do is we can wrap up a lot of the I options. We can add other services that may be necessary. It's really more of a pattern to get used to. It was less important here, but there's options that we can incorporate in the future by having this broken out into another place. Because then we can leave this the way it is, but also utilize additional functionality in the back end without actually having to change client code. I see a lot of advantage to this because there can be a lot of work being done when you add that, and the client doesn't need to know that. So we're hiding that, we're encapsulating that work. So we've done a lot of work here. We're now using this new ISqlExecutor. This is the little trick I was telling you about to maybe make injecting this kind of service easier. However, I did promise a bonus, and I want to use the decorator pattern now to help us with that transaction problem we talked about earlier. So let's go through that process. So I want to have the ability to add transactions or have transactions automatically created for us if I utilize a with transaction extension. So watch this. What we're going to do is we're going to go back to service collection extensions. Well, and what I feel like we need to do here is we need to have the ability to extend our ISqlExecutor to have a transaction. The way we're going to do that, and we're not going to do it here, we're going to add a new class so we get the proper, new class, we get the proper namespace. We're going to create a new class called with transaction SQL Executor. Now, I'm going to leave this as a private class. I actually don't know that we have it. Sorry, not private, internal class. I don't see a need to actually make this public. And what we're going to do in a minute is we're going to create this class, and then we're going to create an extension method where you never have to even know this class really truly exists. Again, encapsulation creates a stronger architecture and leaves dependencies kind of out of the mix. And really now you're just worried about coding it in the way you actually want to code it and using the functionality as needed. So what we're going to do is we're going to say ISqlExecutor. We're going to implement this. Perfect. The way we're going to have to do this, we're actually going to have to inject another executor. So what we're going to do is we're going to inject a separate executor, an internal one if you want to call it that. Maybe that's a better way to do it, or an inner executor. And we're going to store this in a read-only field. So inner executor. Read-only. Great. This is the decorator pattern at work. So in this case, we have an ISqlExecutor, and this with transaction SqlExecutor is wrapping the one that's being injected. We don't know which one's being injected. It could be a SQL Server one. It could be a MySQL one. It could be another with transaction one. They could be wrapped up all over each other. Point is that we have this ability now to wrap these up using the decorator pattern, and we'll see how we can use that here in a second. But for now, let's implement real quick. So we're going to do async here for now. I think we need this. We have an ISqlExecutor. So what we're going to do is we're going to actually return. We don't need this, which is good. Return executor dot execute async SQL connection SQL transaction. And we're going to do this. We're going to say async here. Now, like before, we still need to create the transaction if it doesn't exist already. If one already exists, we're going to just leave it alone and just pass it on through. So what we're going to do is if SQL transaction equals null, then what we're going to do is SQL trans equals, we're actually going to do this. If it's not equal to null, we're going to return executor, SQL connection, SQL transaction. And because we need to await this, we'll do an await. So if it's not null, we already have one. There's no reason to create another one. So let's just pass it on through and go ahead and continue our execution. However, if it doesn't exist, we need to actually create it now. So we're going to say SQL trans equals SQL connection dot begin transaction. We're going to wrap this up. And then all we're going to do is we're going to await executor, SQL connection, SQL trans now. Now we need to store the results. So we're going to say t result equals await, because we also need to commit this transaction. So we're going to say SQL trans.commit. Perfect. And then we're going to return the result afterwards. And there we go. We've now created a decorator for our SQL executor. Well, all right, this is only halfway done because we also need to be able to use this. What I was saying earlier is what I'd like to be able to do is use an extension method as if the SQL executor already had this method on it. So we're going to basically extend ISqlExecutor to have a with transaction method that will then translate it and add this new functionality to the system. So let's go ahead and create that now. We're going to do another public static class, and we're going to call this SQL Executor Extensions. Static ISql Executor, that's what we're going to return. And we're going to say with transaction. So no matter what executor we pass in, we're going to wrap this up with our nice little decorator, and we're going to return that back. Real simple. So we're going to return new with transaction SQL Executor, pass in the inner one, and that's it. To make this a little bit easier to use, we're going to first get this out of here. We need to remember where ISqlExecutor currently is. That's important. So what we're going to do is we're going to go into our SQL Executor extensions, and I think we need to change this to SQL dot, I don't know, should we do abstractions? No, let's just leave it as SQL. Let's see if it works. Inject this. Now the question arises, can we use this directly now? I think so. So let's go back to our product. Let's find our product repository. What we want to do is instead now we want to say dot with transaction, and it didn't work the way I was hoping, so that's okay. We'll come back here and we'll just say dot abstractions. Oops, with transaction. So executor.withTransaction.execute async. I can now delete this and this and this. We can clean this up a little bit because I like my spacing and my tabs to be perfect. And let's see, does it look better like this or like this? Yeah, it looks better like this. So now look at this. This is a lot better. We have now added this with transaction to get rid of that wrapped up transaction. By just simply adding this extension method, we've enhanced the functionality of our ISqlExecutor without actually having to change the interface, which is the part that's wonderful about this. That interface is super simple. We could have easily added that method to the interface as well, but then we've lost some form of flexibility because now we have to always make sure we implement no matter what. Whereas before, we don't have to make that assumption. Now we can just say with transaction based on that extension method, and then we can execute, and this will run within a transaction. But let's prove that. So what I'm going to do instead is I'm just going to throw a random exception here. Okay. If I get rid of with transaction, let's just take that out for a minute. What should happen is we should insert a new set of IDs. The current IDs that we have are 5 and 6. So let's see what happens when this runs and blows up. All right, it blew up because I threw an exception. But let's go look and see if those got inserted. One of them got inserted, but I don't even know what happened to it. Oh, it blew up so early that Yeah, we don't even get the second one. That kind of stinks. Okay, but we should even have had that number 7 in there. So let's stop this. And now let's add back in our with transaction. We'll hit play again. And this time we should not find an ID of 8. It's going to blow up still, but now that transaction should have been rolled back. Oh, they blew up. Let's see what happens. 8 does not exist. So that is showing that the transaction is rolling back even when it blows up, whereas before it was not. Now you've seen another approach to injecting SQL, as well as adding functionality on top of it using the Decorator pattern. I hope this video has provided you with an alternative to performing manual SQL connections within your project. By adding simple abstractions, we can create an easier experience for yourself and future developers. Of course, if you use Entity Framework or other such ORMs, this applies less to you. However, there are still plenty of enterprises that have pushed against using Entity Framework for various reasons. In that case, this solution offers simplicity to connecting to your databases while also giving you control of your SQL. Hey, thank you for watching. Don't forget to subscribe and like this video. We'll see you next time.